Chapter 2, problem number 58, page 51, alternative solution. It's the one with the two stones that are thrown simultaneously, one straight upward from the base of a cliff and the other straight downward from the top of the cliff. The height of the cliff is 6 meters. The stones are thrown with the same speed of 9 meters per second. Find the location of the point where the stones cross paths. So what you can do here is use general theory of relativity. Just imagine that this whole thing takes place in a freely falling elevator. In that situation, it's as if gravity does not exist. Therefore, relative to that reference frame, which is accelerated, the stones will not accelerate. So the stone that is thrown down, we'll call that stone number 1. So we have VO1 is equal to negative 9 meters per second. And then stone 2, we'll call that stone VO2. That would be 9 meters per second, right? They're thrown at the same speed, but opposite direction. The height of the cliff is 6 meters. So stone 1 is 6 meters away from stone 2, which is at a position of 0 meters. And they want us to figure out where the stones meet. So I think you can see they're going to meet at the halfway point, which is 3 meters. To verify that, we can set up the following equation. Okay, for stone 1, we have delta x1 is equal to VO1 times delta t. There's no acceleration. For stone 2, we have delta x2 is equal to VO2 times time. No acceleration. Now delta x1 is equal to xf, where they meet, minus xo1. And for stone 2, delta x2 is equal to xf minus 0, because the 0 meter position is where stone 2 is thrown from, is equal to VO2 delta t. No acceleration. Okay, so we're going to set these two equations equal. Well, first solve this for xf, stone 1's equation. So we have xf is equal to xo1 plus VO1 delta t. Set that equal to this equation for stone 2. So we have xo1 plus VO1 delta t equals VO2 delta t. So take this expression and put it on this side, factor out the delta t. Okay, so let me continue that on this board. So we have VO2 minus VO1 times delta t is equal to xo1. So delta t is equal to xo1 divided by VO2 minus VO1. So xo1 is 6, VO2 is 9, VO1 is negative 9, so we have negative 9. So we have 6 divided by 9 plus 9, or 18, okay, which is equal to 1/3. So in other words, the time interval is 3 seconds. Now, if we want to find xf, we just put that into this equation here. So xf then is equal to VO2, which is 9 multiplied by, I'm sorry, this is 1/3. not 3 seconds. So 9 multiplied by 1 over 3, so we get 3 meters. Okay, so they meet at the 3 meter mark.